All right, just want to do another example with you here. It's kind of challenging. This is number 21. Okay, it's number 21 under practice. When I go to add these together, obviously we need a common denominator. But if I look at both of these fractions, okay, I'm going to try and simplify them first as opposed to weighting. Okay, it would be similar to, you know, if I asked you to add 6/8 plus 12 24ths. Okay, I would hope you'd probably want to simplify these first. I mean, you don't have to. You can simplify at the end. Okay, but I would probably simplify those first before I go to add them together. So the same thing's going to happen here. The second fraction, that's an easy one. What is 7n over 3n simplify to?
7/3.
7/3, okay. So really this just says plus 7/3 back here because the n's are a common factor on the top and the bottom, so they would cancel out. Okay? Now, on the top, if I were going to factor that, okay, the 5n plus 5 is really 5 times n plus 1. Okay? And on the bottom, I could take out a 5. I'd have n squared plus 7n minus 8, which is 5 times n plus 8 n minus 1. So if I look at that, my 5's would cancel. You guys see that? So all I'm left with then is n plus 1 over n plus 8 n minus 1. Yes, no? I erased my work in the blue there, but everybody follow that? Okay. So now I've simplified everything as far as I can, so now I'm going to go through the process of adding them together. In order to add them together, I need a common denominator. Okay? What do I need to do to the first fraction? Multiply it by 3 over 3. What do I need to do to the second fraction? Multiply it by n plus 8 n minus 1. Okay? So, n plus 8 n minus 1, n plus 8 n minus 1. Yeah? Okay? So, the first one's pretty simple. 3 times n plus 1 is going to be 3n plus 3. All over the common denominator, 3 n plus 8 n minus 1. The second one takes a little bit more work. Okay? I have to take 7 times n plus 8 times n minus 1. Okay? Personally, I multiply those two together first, get that answer, and then I'm going to take that answer times 7. Okay? So plus 7, that would be n squared minus 1n plus 8n, so plus 7n minus 8. All over 3n plus 8 n minus 1. Yep.
Wait, why don't you multiply the bottom ones? If you like, why do you multiply the top ones and not the bottom ones?
I'm hoping at the end maybe something will cancel, and so in order for it to cancel, I'm going to have to factor it back out. But I have to multiply the top ones out because don't I want to add the numerators together? And if I want to add the numerators together, I have to take care of my multiplications first before I add and subtract. Order of operations. So I always just let the denominators stay as they are, as factors. I don't multiply them out. It's not wrong if you do, it's just I think it makes more work. But the tops you have to multiply out, because in order to add or subtract fractions, I got to be able to add or subtract my numerators, and I can't add or subtract until I'm done with all the multiplication on the top. That make sense? Okay. So now I got 3n plus 3 plus 7n squared plus 49n minus 56 all over my common denominator. Right? So I can just add my numerators together and it's all over that common denominator. Then I can combine my like terms. Is the camera low enough?
Oh, yeah.
Okay. I'll get 7n squared plus 52n minus 53 all over 3n plus 8 n minus 1. I'm guessing that's not factorable. Does anybody have the answers pulled up? Is that the answer they have? That's the answer they have? Okay. So then you are done. What values of n could n never equal? Negative 8, 1, but also 0. Because in the original problem, we did just have an n right there, and if n was 0, that would put a 0 in my denominator, which we can't have. So n cannot equal 0, n cannot equal negative 8, and n cannot equal 1. Okay? Alright, so just another example of some addition. I'll do another one here if you guys want.